guys, Rosie the Riveter here, going to help you with the 3A-8 application problem, so let's get straight to it. Jocelyn throws a ball up with an initial velocity of 32 feet per second at a height of 240 feet. Use the equation h of t equals negative 16t squared plus v sub 0 t plus h sub 0. And the first thing we want to know is, when will the ball hit the ground? Before we start trying to answer this question, I want to talk to you a little bit about how to interpret this formula, because this is a formula that we get from physics and from science class. So you may have seen similar things before, but I just want to kind of tell you what some of these variables mean. So when you see h of t, that means height as a function of time. So in this formula, any mention of the letter h is going to refer to the height of the ball. T is going to refer to time. And then it says negative 16 times time squared plus v sub 0. V sub 0 is your initial velocity. That means the velocity at the very start. When Jocelyn first throws the ball, how fast is it going? Well, we actually know that because it said that the initial velocity, or v sub 0, was 32 feet per second. So when we start plugging things in, we know that that 32 is going to go in place of that v sub 0. Okay, the next thing in my formula is that initial velocity is multiplied by time, and then we have h sub 0. H sub 0 stands for initial height. So anytime you see that sub 0, that means your original or initial, oops, not velocity. Your original or initial whatever you're talking about. And we also know the initial height. That was told to us in the problem. The initial height was 240 feet. So now that we're ready to start filling things in, there are at least two pieces of information we know. Now, another piece of information that we know is the question is asking, when will the ball hit the ground? If we want to know when it's going to hit the ground, that implies that the height is 0 feet because it's laying on the ground. So that's the information that we're going to use to fill in this h of t. Okay? So we want to solve this equation for when the height is 0. Right, so let's go ahead and fill it into my formula. In place of h of t, I'm putting 0 equals negative 16 t squared. We're looking for time, so that's going to be my variable that stays in the formula. Initial velocity, we've already said, is 32. Again, t, I don't know. And initial height, we've already said, is 240. Okay, so now I have this quadratic formula that I have to solve. Remember that if you're trying to solve a quadratic formula, the first thing you need to do is see if you can find a GCF and factor it out. Well, I know that 32 is 16 times 2, so I'm thinking maybe I'm going to be able to factor out that negative 16 there, but to check to make sure, I'm going to pull out a calculator and divide 240 by 16, just to make sure that that's a factor. By 16. And it's 15, so that means I am going to factor out a negative 16. Do factor out negative, because we don't want to be left with a 1 there, because we know our factoring is just much easier if that first coefficient is 1. So we're going to pull out a 16, and we're left with t squared minus, because 32 divided by negative 16 is negative 2, and then minus, again, because 240 divided by negative 16 will be negative 15. And now I'm ready to factor, and this is the trinomial that I'm going to be trying to factor here. Okay, so now I'm ready to divide off that common factor so that it's kind of out of my way while I'm factoring. So I'm going to divide both sides of my equation by negative 16. 0 divided by negative 16 is 0, and over here, those cancel each other out, and I'm just left with a nice, easy to factor t squared minus 2t minus 15. So I'm going to go off to the side and draw myself a little table, and I'm looking for factors of negative 15 With the sum of -2, honestly, with 15, the very first thing that comes to my mind is 3 and 5. Because it's negative, I know one of these is going to be negative, so I'm looking over to my sum to figure out which one should be negative. My sum is also negative. That means the larger number is probably going to be the one that's negative. And sure enough, 3 plus -5 is -2. So I know it's going to be 3 and -5. So that means I now have t plus 3 and t minus 5. So to solve this, I'm going to set each of those factors equal to 0. Right, so let's wait for it to stop. There we go. So t plus 3 equals 0 and t minus 5 equals 0. Haha, t minus 5. Okay, when I solve this one, I'm subtracting 3 from both sides, which gives me t equals -3. And when I solve this one, I'm adding 5 to both sides, which gives me t equals 5. And here's the part where the application is important to really think about what you're doing. Remember that the initial question was, when will the ball hit the ground? And t is representing time. Well, we know that the ball is not going to hit the ground in -3 seconds. Therefore, this solution is not valid for this particular application. The solution that I'm going to report is in 5 seconds, the ball will hit the ground. So my answer is the ball will hit the ground in 5 seconds. Okay. Oh, let's move me out of the way. So now we're ready to look at part B. So for that, we're going to go over here. Part B wants to know if Jocelyn wanted to catch the ball at the same height at which she threw it from, how long or how many seconds would it take for the ball to reach her? So what that means is, picture we've got little Jocelyn standing on top of the, Empire State Building or whatever building is 240 feet high. She has this little ball. I'm not an artist, okay? But she has this little ball and she throws it and it kind of arcs up and then starts falling back down. We want to know how long it's going to take for this ball to go up and travel back to where she started. So before we were looking for how long is it going to take to hit the ground. Now I want to know how long it's going to take before we're right there. Okay, so what that's going to change in my problem is h of t. I'm no longer looking for when h of t is 0. I now want to know when it's at this height, which recall that the initial height was 240. Okay, so we want to know how many seconds it's going to take for h of t to equal 240. So when we plug in our information, most of it is going to be the same. The only thing that's different is instead of 0 equals, I'm going to have 240 equals. My -16 is always going to be there. Plus 32 is still my initial velocity. And plus 240 is still my initial height. So now when I start solving this, the first thing I'm going to do is I notice that, let's see, what do I want to do first? Okay, I'm gonna go ahead and subtract off this 240 first. Because in order for this to work, in order for solving by factoring to work, I have to have a 0 over here. So I can do that really easily by subtracting off that 240. And now I'm just left with this. Again, I need to factor out my GCF, but this time the GCF is going to be -16 t, because both of these have a t. Before we couldn't factor out the t because that constant was there, but now that constant's gone, so what I'm left with is t minus 2, because from this first term, if I divide -16t, I get, I'm left with 1, which is why there's nothing in front here, and then t squared divided by t is t. For this one, when I divide 32 by negative 16, I get negative 2, and t divided by t is 1, so that's why this is left behind. So now, my factoring is done. All I've got to do is set each of these factors equal to 0. So negative 16t equals 0, and t minus 2 equals 0. I'm going to solve this by dividing by negative 16, which leaves me with t equals 0. And over here, I'm going to add 2. Oops, I don't know why I did that. Over here, I'm going to add 2 to both sides, which gives me t equals 2. Again, this is an application, so you've got to think about which of these solutions makes sense. We're talking, t represents the time it's taking for this ball to travel. A time of 0 seconds, we know that it started at 240, which is why we got 0 seconds, because the ball is at 240 feet at 0 seconds. But that's not the information we're looking for. What we're looking for is how many seconds it took before it got there again. So the solution that I really want to report is t equals 2 seconds. This one is not really helpful. So then my solution statement is the ball reaches 240 feet after 2 seconds. All right, that's it. If Halloween hasn't already happened, happy Halloween. If it has, hope it was good.